My name is Xochitl Atanasio. I am student at the Advanced Materials Research Center. This research is called Evaluation of Mechanical Properties in Ternary Systems of Aluminum Magnesium Silicon and Aluminum Magnesium Zinc under conditions of AT8 thermal treatment. Two ternary systems, aluminum magnesium silicon and aluminum magnesium zinc, considered to have high mechanical strength, are studied where the correlation of heat treatments and plastic deformation, T8 heat treatment, as well as the effect it may have on the mechanical properties, are evaluated. Now, aluminum is a metal that lacks high mechanical properties on its own, so it is necessary to alloy it with other chemical elements such as copper, zinc, magnesium, silicon, among others. To increase its mechanical properties, in addition to alloying it with other elements, it is necessary to use one of two ways of hardening, which can be by heat treatment, which causes precipitates in the aluminum matrix, and by plastic deformation, which can be by rolling process, as shown in Figure 1, where the sample is subjected to an area reduction process, in which dislocations are generated throughout the alloy. Typically, aluminum alloys for casting are subjected to T6 heat treatments, which consist of a solubilizing heat treatment, quenching and artificial aging heat treatment, as shown in the diagram in Figure 2, right hand. This process allows to obtain an increase in the mechanical properties of the alloy. However, there are few investigations that discuss the relationship between both routes, cold plastic deformation and precipitation, which corresponds to AT8 heat treatment, as shown in the diagram in Figure 2, left hand. Therefore, the effect of this T8 heat treatment on the mechanical properties will be evaluated. To obtain the samples to be studied, the following methodology was followed as shown in Figure 3. As a first step, the melting of each of the ternary systems was carried out. The furnace was heated to 740 degrees Celsius, and the quantities used were added to the crucible for melting. At the end of the casting, the mixtures were poured into cylindrical molds, where two solid samples of each ternary system were obtained in cylindrical form. The next step is to extrude these samples to obtain rods of approximately 200 millimeters. Once the rods were obtained, the samples were cut into small sections to carry out the solubilized heat treatment, which was carried out in a Felisa muffle for 5 hours, at a temperature of 570 degrees Celsius for the system containing silicon and 465 degrees Celsius for the system containing zinc. Once these samples have finished the solubilization cycle, cold deformation is carried out on each ternary system, with a reduction of 5, 10, and 15% for each sample. To finalize the experimental stages, the samples are subjected to thermal aging treatment at different times, 30, 60, 300, 600, 3000 and 6000 minutes, with a temperature of 200 degrees Celsius for the samples containing silicon and 140 degrees Celsius for the samples containing zinc. After obtaining the samples, we proceed to the characterization of the samples. A chemical analysis was carried out on the samples obtained to verify if the constituent materials of the ternary systems were present or if any of them, such as zinc, which has a lower boiling point than aluminum and magnesium, were lost during casting. In Table 1 we can observe the results obtained by ICP and the values added at the time of fabrication of the samples. The results tell us that the fabrication of the samples was successful. According to the results obtained by EDS mapping in Figure 4, it can be seen that both ternary systems aluminum magnesium silicon and aluminum magnesium zinc, in extruded condition, present a higher homogeneity of the alloying elements compared to the samples in extruded condition, where the highest concentration of elements such as silicon and zinc are found around the pores and cracks. In the Vickers micro-hardness tests, for the samples containing silicon, Figure 5b, it can be seen that, yes, there is an increase in hardness after the samples are submitted to the thermal treatment of solubilization and after the deformation process by rolling. However, the maximum hardness value obtained is in the reference sample, without deformation process. On the other hand, the samples that containing zinc do not present an increase in hardness now of being submitted to the rolling process and the thermal treatment of aging. The maximum value of hardness is obtained when the samples are submitted to the thermal treatment of solubilized and without a plastic deformation. The conclusions are as follows. In the characterization by chemical analysis, The results obtained by ICP show the presence of constituent elements, ruling out losses during manufacture. According to the microstructural characterization by EDS, there is a homogeneous distribution in the alloy materials in both ternary systems after extrusion. Finally, according to the hardness tests, an increase in hardness is observed only in the aluminum-magnesium-silicon ternary system, being favorable to T8 heat treatment. While for the aluminum-magnesium-zinc system, the T8 heat treatment could negatively affect the mechanical properties. This is what has been obtained so far in the investigation. I thank you for your attention.